26 notes and practice video. So basically just going to start with our warm-up, go through kind of the same type of things we did from lesson 25 in terms of the knowledge, and then really just learning about how we can check this in the graph. Alright, so let's get started. So the warm-up problem here asks us to basically do what we did in lesson 24, so solving those radical equations. Alright, so as I write it, just think about when you're solving the radical equations, the main thing you want to do is isolate the radical. So even when I'm just kind of copying this down, I'm looking for where's my radical, what's on the same side of the equal sign, right? So it's this plus 3, so I need to cancel that, right? So we're just going to do opposite operation to minus 3 to both sides. Okay, so now that I do that, I'm going to get the cube root of, and then I got 6x minus 5 equals, and now I've got the square, negative 2 and negative 3, I get negative 5. Okay, so what was our next step? Remember, we got to cancel this cube root of 3. So we cancel it by doing whatever that power is suggested by the index. So since this is a cube root, then we do it to the third. If it was a fourth root, we do it to the fourth square root, you square it, whatever. So the cube root and the cube cancel. I get 6x minus 5, so 6x minus 5 equals, and now I've got negative 5 to the third. Okay, and feel free to use your calculator here if you need to. Like, say you weren't sure about that, you want to double check yourself. Type in your negative 5, use this button to get that exponent, and then to the third, you get negative 125. Obviously, if you can just do it mentally, then even better. All right, from here we need to cancel and solve. So I'm going to add 5 to both sides. Once I do that, I'm going to get 6x equals negative 120. So then once I get to this place, now I'm going to say, okay, I need to get solving for x. So I'm going to divide by 6, divide by 6. So now I get negative 120 divided by 6, which is going to give me negative 6. Okay, so, oops, sorry, my bad. Just kidding. Negative 20. Whoa, no. Negative 20, my bad there. All right, so I'm going to get my negative 20, okay? And now I need to go through and do the process to check it. Okay, so let's review how we check it. Now again, in this lesson we're going to learn how to check this by graphing, but for right now, here's what we would do. We'd go in here and I'm going to type this whole left-hand side of this equation in. So I'm going to hit this button, the nth root, so I can get my cube root, and then I'm going to go inside, and then when I go in here, I'm going to get 6 times x. Well, what's x? It's negative 20. So 6 parentheses negative 20, close parentheses, and then I've got my minus 5 inside the radical, and I'm going to go outside, and I'm going to put what? Plus 3. So I go plus 3. And what do I get? I got negative 2. Well, what was it supposed to be? Negative 2. Alright, so that means it checks. If I get anything other than negative 2, then I would have to say it was no solution. So again, it's not no solution. Alright, so screen 3 here just kind of works you back through what we do to solve a rational expression equation. The main thing that we're seeing here is people having struggles with finding that LCD. Okay, and then we multiply it through, divide, simplify, solve, check your solutions, which again we're going to learn a new way to check them in this lesson, and write the validated solution. So let's look at a pre-done example here. Okay, so here we have 4 over x plus 1 minus 1 over x equals 1. So first thing I would always say is if you don't see a denominator at all, remember it's implied to be a 1, so toss a 1 down there. Now, let's find that LCD. So how are you going to do this? Well, if you need to factor in any of the denominators or take out GCF, whatever, then you need to do that part first. Now, in this case, there's no factoring to do. So what are we going to do? You're going to write down whatever's in the first denominator. It doesn't matter. Anything that's there other than 1. So in this case, it's x plus 1, so we write that down. Then we go to our second denominator. We see an x. Well, I don't have an x value here, so I'm going to have to put that out here as a GCF. Now I have the 1, but again, anything times 1 is just itself, so we don't have to do anything with that. So we're going to get x plus 1 as our LCD. So then what we're going to do is we're going to multiply x times x plus 1 through to each of these numerators, the 4, the negative 1, and the positive 1. So you'll see here how you have x plus 1, x plus 1, x plus 1. Now we're going to divide out in each term. So in the first term, the x plus 1's cancel, so great. We do 4 times x, well that's 4x. Then, in the next term, the x's are going to cancel. Well, 1 times x plus 1 is just x plus 1. Remember, though, this is a negative, so that's really going to flip those signs. So you can get negative x and negative 1. And then lastly, this one should be pretty straightforward because you're multiplying by 1 and there's no other sign. So x times x squared, and x times 1, 1x. Okay, when you get here, Then you need to analyze, what do you have? Do you have a squared term? Do you have just a power to the first? Because if you just have it to the first power, in other words, a linear equation, then basically it's just an algebra 1 problem. If you have a squared term, then you need to use your skills that we had from the last unit for solving quadratics. So what should you do? Get it set equal to 0. I see the x squared is on the right hand side, so I'll move everything over there. So you add 1 to get that here. Combine the 4x minus x to get 3x, then subtract it. 1x minus 3x gives you negative 2x. So now I'm left with this. 0 equals x squared minus 2x plus 1. So you could solve this by factoring or graphing or quadratic, any of them, quadratic formula. In this case, the factoring is pretty easy, so I just did that. Multiply to 1 and add to negative 2 should be negative 1 and negative 1. Since these factors are the same, this is what we call that double root. So we're going to go ahead and see that that's just going to give us our one solution of 1. Then you could check it by putting it in the calculator. Notice how I showed that here. You would just plug a 1 in, because that was the answer we got, for where you see an x. When you do that, you get 1. Well, what was it supposed to equal? 1. 1 equals 1. Good. That's a validated solution. So again, this is just looking at the same thing we looked at lesson 25, just another example of it to keep practicing these skills. So let's look at one that wasn't pre-done. So here's this one. Okay, so again, I'm always going to throw a 1 under something I don't see, so now I need to create my LCD. So before I even do that, I say, is there any factoring that needs to be done? So no factoring, no GCF. So what do I have in this first term? I have x minus 1. Okay, so I have my x minus 1. What about in the next term? I have a 2. Okay, I got to include that. 1, well, that doesn't change anything. So here's my LCD, 2x minus 1. Okay, so we're going to multiply that through for every single part here. So for all three aspects, that's what we're going to do. So we're going to do 2x minus 1 times 2 over x minus 1. So as you see, that's this first term equals, and then I'll switch colors for emphasis here that we're doing each term separately. So now what do we have? 2x minus 1 over, well, what was initially here? X over 2. So x and then 2. And then lastly, I'm going to write out what I have here. So I've got the 1 there. So I'm going to have 2x minus 1 over 1. Okay, so now I'm going to go through and cancel. So let's do that on each part. Okay, so we'll start over here on the part with blue. Well, the x minus 1s can cancel, right? So now you just have 2 times 2. Okay, well, that's just 4. All right, so now what? I'm going to go to my next set. So here I could cancel these 2's. So now I'm going to go x times x is going to give me x squared. And then x times negative 1 is going to give me negative 1x. And then for my last term, I just have this 1 denominator, so that's not going to cancel anything. So I'm just going to distribute here. 2 times x is going to give me positive 2x. And then 2 times negative 1 is going to give me negative 2. So now I'm going to say, what kind of equation do I have? Oh, I have this squared term, so it's a quadratic. So I need to get that set equal to 0, so I'm going to do that by minusing away the 4. When I do that, then this, of course, is 0, and then this is x squared, and then I might as well combine my other like terms. So here we go. Negative 1x and positive 2x. Negative 1 plus 2 is 1x. And then we've got negative 2 minus 4. Negative 2 minus 4 is negative 6. And now you can solve this any other ways. Factoring, quadratic formula, graphing, whatever works for you. What we're going to do here in this case is just to factor it. So to multiply to negative 6 and add to 1 should be x plus 3 and x minus 2. All right, so we get that. Again, these are like equals 0. So if x plus 3 equals 0, what is the solution? Oh, it's negative 3. And if x minus 2 is a factor, what's the solution? Oh, it's positive 2. Okay? Now, we can check these by going back and plugging them back into this equation and making sure both sides equal each other. So just to show that briefly, because then we're going to learn a new method, like I said, in the rest of this lesson. So I go 2 over, and it's supposed to be x minus 1. Well, let's start by putting the negative 3 here. So if I go negative 3 minus 1, okay, I get negative 0.5. All right, let's do the new line, and we'll do the right-hand side of the equation. So it's x. Well, what's x? In this case, we solved. We got negative 3 divided by 2 plus 1. So what do we get? Okay, so when we do this, oops, sorry, I didn't type that in. Make sure you hit the right-hand arrow key there so it's not part of the denominator. Notice how these match. So then that means the -3 answer checks out. So now I'm going to check it with the 2. So I'll just replace these -3's that I had with 2's. 2 over, whoopsies. And now you'll notice both of them equal also, so this answer also checks. All right, so again, make sure you're getting this practice. Make sure you're doing the lesson 25 practice and this lesson 26 practice that involves this same skill. So now from here, let's show how we can check these by graphing. So we can check our solutions by graphing. How do we do this? Well, we're going to graph the one side, the left side, we're going to write y equals, and whatever's on the left side of the equal sign. Then we're going to write y equals, and whatever's on the right-hand side of the equal sign. And then what we're going to do is we're going to look for where they cross. Okay? It won't show any extraneous solutions. So if you get a solution you think is correct, but then you graph it and it doesn't cross at that x value, it's an extraneous solution. Okay, now graphing's not always ideal. Sometimes the graphs are hard, ugly to read. Sometimes it looks like the graphs don't cross, they really don't. So it's not a good way to solve, but it's a good way to check. So let's show that. So here's the first question we did, right? We did this problem right here. All right. So what we're going to do in the Desmos calculator is we would put y equals, and then we're just going to put this whole left-hand side into that first line. And then we're going to put a second line, y equals the right-hand side. Well, in this case, that's just a 1. All right, so then what you'll see here is the blue line represents this line 2, and the red line represents the line 1. So look at the graph, and then look at where they intersect, right here at 0.11. So what is the x value? We don't even care about the y value. We care about the x value. Is this the same as the answer before? Absolutely, x equals 1. So we looked for where they intersected, and then we looked for that x value. So let's look at it for that other example that we did, right? This is the one we just worked through. All right, so here we go. Now I'm going to show you how to do it, not where it's just pictures of it, but it's in live time. So we see this, the 2x minus 1 is on the left side. So I'm going to go to screen 9. I'm going to type y equals 2 over x minus 1. Okay, so there we go. All right, so now I go back here, and I'm going to do y equals x over 2 plus 1. Okay, so I go to the second line, and I'm going to go y equals x over, hold on, I think I might have messed that up. What was that equation? X over 2 plus 1, my bad. So x over 2, make sure you right-hand arrow click to get out of it, plus 1. And what we want is where they intersect. So click on the point here. What's the x value? It's -3. So it's -3. What's this x value? 2. 2 and -3. So those are the solutions. Well, weren't those the same solutions we got when we did it here? -3 and 2. So those are the solutions, and we confirmed them. And then basically you can do this every time. Now do keep in mind, like here's one example, for instance, where if you type the left side in here and the right side in here, here's what you'd see. Okay? Now clearly it does cross at -1, so that would be an answer. However, it's all over the place. You can't tell if it does it cross here, does it cross here, does it cross here, does it cross here. So this is where it's hard to solve by graphing. It's really only good for verifying answers. So like on this problem, you say, oh, is it -1? Yes, it is. And you don't even have to worry about the rest of this stuff, okay? All right, do keep in mind you can also use this same method to do this when we did the radical equation, so the stuff we did in lesson 24. So, for instance, how do we solve this problem, right? Well, we need to isolate the radical, so you're going to add 2 to both sides. When you do that, we get here. Then from there, I need to cube both sides so that I can cancel it. Well, -1 cubed is -1. So my solution would be -1. I could check it by plugging it back in. I get -3 equals -3. Since the two sides equal each other, I know I'm correct. Well, now, what do we do it to check it in the graph? I'm going to plug the left side of the equal sign, which is this right here, into line 1. Then I plug the right-hand side of the equal sign, which is this right here, into line 2. And then I'm going to look at the graph. Here's the graph. Where do they intersect? Right there. What's that x value at? -1. Oh, look, the solution's -1. So they match up. And again, keep in mind, too, you could do one, for instance, this one, where if you solve this one out, you get -13, where if you check it, you get -4 as the answer. But if you plug that back in, you get the square root of -13. Well, that's not a real number, so this is not a solution. Well, what would that look like on the graph? Well, if you were to graph these, you'd see the two graphs. Notice they do not intersect. So if the graphs do not intersect, there's no solution to the equation. All right, hope this helps. Make sure you get your asynchronous work done for both lessons 24, 25, and 26. And hopefully this helped you both with learning how to solve the rational equations back like we did on screens 4 and 5, and seeing how we can use the Desmos graph to check for our solutions, looking for the intersects and what the x values are.